My name is Rebecca. I joined SAP in March 2021. And from this day on, I'm working as a C++ senior developer in the HANA deployment infrastructure, in short, HDI team. And yeah, so it's no surprise that I will tell you today something about HDI or the magic behind CAP. And I will show you how a CAP entity becomes a database artifact with all its dependencies. So what I want to do with you the next 25 minutes is to build an application. And of course, the basis for an application is a data model. And this data model you have to transform to a database persistency. And every database persistency is represented by a dependency graph. And so let us imagine that the dependency graph or that the database persistency or the dependency graph which we want to transform to a database persistency looks like this. Okay, as you can see, you see nothing. But if you would scroll in, then you could see that every node in this graph represents one database artifact, and the vertices are the dependencies between these artifacts. So who wants to do this now, also transform this dependency graph to a database persistency manually with a lot of SQL scripts and a bunch of create and SQL statements? Okay, nobody? I have to be honest, I want also not to do this. So let's see if we could do this on an alternative way without using this bunch of SQL scripts or this cumbersome SQL scripts. And so let's start to create the application. So let's think about what application do we want to create today. So I would propose, because it's everything a little bit magic the next 20 minutes, I would propose that we create an application for a fictional wizard school like Hogwarts, for example. So, and where we can create the applications, that's of course in SAP Build. Okay, so we are in SAP Build and we create the application and we want to create a full stack application and in detail the full stack Node.js application. I will not do this now because I have already created this. You can see here's our wizard school and I opened it already in SAP Business Application Studio. And here we have our blank project for the wizard school. So now the nice thing in Business Application Studio is that we have here nice guide center and a guide who leads us through step by step for developing such an application. So we can here step by step follow this guide and create our application. So of course we need first a data model, then we add some sample data as well as some application logic, add some unit testing, and at the end, of course, we need the UI. In my demo, I will only do the first two steps. That's enough for seeing an application. So let's start. And the cool thing, I have an assistant for creating this data model. And I say my assistant what I have or what I want. What? Okay, of course, it's a demo and not everything is working. Okay, so I said my assistant, I want to create a data model to manage a fictional wizarding school like Hogwarts. And yeah, there are different houses and the students belongs to professors teaching courses with different credits and students can enroll in many courses. So let's see what my cool assistant has done from it. Okay, he's created, the assistant is created for entities. This looks good, all the entities we wanted. And so we accept this proposal. Okay, now you can see that the data model and services are created. That's great. So we have done the first step. Now it would be cool when we had some data as well. So we ask our assistant again. And now we say, okay, now please generate me some sample data. So who can remember some students and professors from Hogwarts? Yeah. Yeah, for example, and the students, of course, Dumbledore, Dumbledore's own professor, right? And Yeah, and Harry Potter. So let's see what our assistant has done from it. Oh no, he's still thinking about this. I don't know if he knows the story. So yeah, what are the houses? Gryffindor, right? Okay, let's see. We open the data editor. And then we say check first the students. Oh, as we obviously he knows the story. Harry Potter and I heard I was Dumbledore. Okay, that's great. So I would say we have the first steps for our application. So let's start the application. And then after some initializing steps, a new browser fenster should open and we could see or we should see our application. Here we go. And we see we have created our first application. And we have already some entities like the students and the houses. So let's check, for example, the students. Here we are. For example, Luna Lovegood, and Luna Lovegood is living in the house Hufflepuff. Okay, great. So what do you think? Have we now already created a database persistency? But the answer is no, we didn't. So what we have to do now is, of course, add HANA. And for this, we have to add some features first. Now we have added the HANA features. And then you can see here, we have the possibility to connect a database connection, or to bind a database connection. And here we have to bind an HDI container. This HDI container you can create before in the BTP cockpit under instances, and then you can create here the HDI container. You choose HANA schemas in HDI container and choose the HDI shared plan. Then you select your space and give a meaningful name. I have already done it, so I have not to do it. You can see here's our container, the wizard school. And exactly this container we will now bind to our project. Okay. He will ask if we really want to find this. Yes, we want to do this. Okay. So now what we have done up to now, we have created such a dependency graph. Okay, I have to say this graph is not so big, and of course you can say me, Rebecca, that's not magic. This I can do really this for entities. I can do this manually with SQL scripts. Yes, I believe you that you can this, but keep in mind the real world dependency graph looks like the graph on my first slide, and this was still a small real world dependency graph. So we use only this example, so it's make it too easier, so it's easier to follow along with only these four entities. So what we want to do now is we want to create from this dependency graph a database persistency. And as I said you, we don't need some SQL scripts and create statements and so on. We only click this nice rocket button here. Let's do it. And then you can see that here some folders are generated. And in this then folder here, you see that for every our entity, one file is generated. So for the courses table, for the houses table, for the professors tables, and as well as the corresponding views. So now the question is, what has happened in the background when we started or triggered this deploy button? And as I'm switching back to my slides. Oops, it's not. Okay. So we have a database persistence model. In our case, we have the houses, the students, and so on. In this example here, we have only 3 database artifacts, so one table Y, a view X, and a procedure Z. And then we have seen that for every database artifact, one or design time object, one file is generated. For the view, the HDB view file, for the table, the HDB table file, and for the procedure, the HDB procedure file. And then when we click this rocket button, something, or this is so to say, the target state which we have defined. So we wanted to, that's our database persistency we defined, and we defined this in our case with these entities, but also from the entities, the files are generated. And then at a certain point, we say, okay, now our dependency graph is ready, and we want now to transform this dependency graph into a database persistency. And what is then happened, this is when we click this rocket button, then the files are passed, read and passed, and then for every database artifact is figured out what does this artifact provides and what is required. So for our table Y, the table Y provides something what is called Y, and it requires nothing. The view X provides something what is called X, and need access to something what is called Y. And the same for the procedure. And then from this, the dependency graph is built. And the dependency graph is taken for 2 things. The first thing is it's figured out when it's built if something is not valid or if something is missing. And when this is the case, the deployment will not start. But when the dependency graph was built successfully, then the graph itself is taken for the deployment. So the dependency graph, during the deployment, the dependency graph is traversed and every node is transformed to a database artifact. And now let's see if we can see this also in our application in the block. So we go back to our application and we did the deployment. And now let's see what we can find in the deployment block. And here we see the deployment started here. And then our files are added. Here we see every HDB table file for every entity is added. Then obviously the dependency graph is calculated and built. And then the deployment, this means the traversing through the graph is started. And every node is transformed to a database persistency. Okay, that's cool. And now let's see if I have not promised you too much, if we have really database artifacts in the database. And for this, we open the Database Explorer. And the table is now added, the database. And then we can have a look into our tables. And let's see. Here we are, the courses, the houses, and the professors are there. Okay, so let's check if we have already data. And oops, there's no data. Let's check why. For this, we open again the data editor. And here we can already see, okay, the sample data we have already added is only for testing and demo, but not for our deployment and production system. So we have also add some initial data, and you can do it via import or also manually. So we do now 2 lines manually. For example, Albert Dumbledore and Pomona out. Okay, spelling is not correct, but that's okay, I think, for the case. And now what we have to do again is, you know it now, we have to click this rocket button. And what you can see then is that here the further folder is added. And this is a data folder. So obviously, also for the data, the files are generated, and then in the background, the files are deployed. So let's check this in the deployment log. Here we see the table, the data files are added, and the 2 records are inserted. So let's check if it's true. We see, or check the table again, and here we are, our 2 professors are added. Okay, so that's one thing. The other thing is, I've told you that from the entities, the files are generated. So you have, of course, also directly the possibility to create the files for yourself. So, for example, we have here a nice editor for this. And now let us assume that the students and the professors should own some magical items, for example. And so we create now a table for the magical items. I name it also magical items. Create the table. And then we have to define here our columns. I have prepared the statement. And so we have the ID and name, and of course, professor and students column. And then let us also add a view. For example, a view which only shows the magical items for the students. Okay. And yes, here we add what we want to select from this magical item table. And here we are. So I think now everybody knows what we have to do. Yes, we have to click the rocket button. And let's check. The deployment was successful. And here we see our magical items, and also our view was added. And so let's check this again in the table. And we check here again. And we see in the table, we have now also our magical items table. And we should find in the views our magical items student view. Okay, that's great. So what I have shown you up to now was the so-called initial deployment. So we have created our entities the first time and deployed it to the database. What you can also do is a so-called redeployment. So let us assume Jane Rowling is now the opinion that it's not a good idea that the students own also magical items because they are doing so many stupid things with it. Only professors should own magical items. So for our developers, as I showed you, you have only to define the target state. Okay, that's easy. I don't need some alter statements. I only remove the students column. And now I have to click the deploy button. And then let's see in our deployment log. Oh, I can see here an error. Let's check why. Okay, the redeployment, I told you this is a called redeployment of the view failed, and the reason is that the invalid column students. Okay, yeah, that's right, because we removed the students column in the magical items table and the view select from the column in the magical items table. So what we have seen here now is that when you do the so-called redeployment, then not only the database artifact which you have changed is validated, but also all artifacts on top of it. And when one artifact on top of it is getting invalid, everything is rolled back and you end up in the old state. So this deployment is not successful. So this means you have a so-called transactional all or nothing principle. With plain SQL, of course, you could do it. You could change the table and deploy it. the view would get invalid. But here you cannot do this, and this means that you have a strong guarantee of consistency, and you can be sure that you have every time in valid state when you have or when you have had a successful deployment. So let's remove it so that I can show you as the last example. Of course, you can also not only create such easy database artifacts, but also some advanced database artifacts, which we have already seen today. For example, calculation view. I will do it only short. For example, for the props. And when we create this, here we have a nice graphical editor for creating these calculation views, and this will open now. And then we add. That's a very, very easy one, but only for showing this case. So we choose, for example, our professors, and then we define some mappings, for example, the ID and the name, and we call it prof name, so it's a clear name. Okay, and then, of course, we have to click our Rocket button, and then we should find also our calculation view in our database. So the deployments are successful, then let's check the column views, and here we have our professors. Okay, so what we have seen, we have created a target state, and then we click this magic rocket button, and then something in the background figured out the dependencies and transformed all our database or design time objects into runtime objects. And this was triggered from this rocket button has a name. And this name is HANA Deployment Infrastructure, or also in short, HDI. So why should we choose HDI? We saw that the developers define all objects by source files. And then the source files are used to generate and deploy the runtime objects to the container. So first, the dependency graph is built, and then they are used to deploy the runtime objects. It supports the most standard artifacts like tables, and as we also have seen at the end, the advanced HANA artifacts like calculation views. It determines the current deployment order by building this dependency graph. We have the possibility to redeploy this, as we have done with the magical items. And what we have also seen, the example for the magical items is we have a transactional all or nothing principle and the strong guarantee of consistency. And yeah, if we have done it, it can be generated from higher level languages like CAP CDS. And yeah, there's still more to this HDI world, but this is the end of my talk, and yeah, perhaps the beginning of your HDI journey.
Right.
With this, thank you, and open for Q&A.
Thanks a lot, Rebecca. That was truly a magical presentation. So giving us a bit of insights into HDI and what's happening behind the scenes. Are there questions from the audience that we want to hand over to Rebecca? Right, it doesn't seem to be the case. So that was very conclusive in that case. Oh, there is some. I was just, yeah, no, now we have 3. So go ahead.
Yeah, one question. So if you can answer this one, then I don't have to chase Thomas down afterwards. I have a question in relation to sharing HDI containers across database tenants. And in particular, the setup here would be that we would work with HANA Cloud, building HDI containers just like you do, but we want to share the contents of those with another SAP product, namely DataSphere. Would you know if it's possible to share HDI containers across tenants?
To share HDI? Schrader?
Is that going to be a topic for later on?
Yeah.
Yeah. Okay. That's cool.
Yeah.
Good question.
Just for our online audience, there will be a follow-up offline conversation on that, as far as I understood. And over here, Gregor is probably also interested in the very same topic. There we go.
One answer is if you want to use synonyms, then it must be on the same HANA stack. Otherwise, you have to use virtual tables.
Yeah, I also had a question. I'd like to deep dive a bit more into the users, the different ones, the DI user, object owner, and so on, and whether you can suggest any enablement materials other than the documentation. Anybody like talking, doing the deep dive into the HDI container that goes a bit beyond what you just showed?
Yeah, you will find a lot of blogs from Schrader, for example, and Volker Sagau. I think they are very helpful.
Yeah, you could
You throw it over just so everyone can, and don't hit her. We still need her. If you can just repeat, Schrader, that would be great.
So I was just saying that we have a blog maintained where we have like a series of best practice collection written by a couple of our PMs. I can share that with you and share the link in the chat. That's good.
Yes, we'll share that also via the HANA TechCon channels. Right, are there more questions? Anyone? It doesn't seem to be the case. So again, Rebecca, thanks a lot for bringing us to Hogwarts. That was amazing.